Okay, welcome back. So we're looking at the quotient rule now. The quotient rule is formulaic in the sense that you just go through and apply it. So we've got where we've got our function, our f of x function in the form of a quotient. Then we'll have the derivative will be equal to, and it doesn't matter whether you do it b to u or u to b, u dash b minus b dash u, and provided you stick to it, and v squared, b squared. So u and v, so that's fairly straightforward. So we're applying u dash, 3x squared, and b dash, which is 2x, and then putting all of this together. So y dash will be equal to 3x squared times b this is where it's probably paying off the part there, minus b dash was 2x and x3 minus 1. And v is all squared. So put it in brackets and square it. So we're going to do the expansions, remembering to make sure you keep your minus sign properly. So don't forget this one because it's a minus 1 in disguise, isn't it? Talked about that before, minus 1. So what we'll have is 3x squared times x squared is 3x4, plus times 1 is 3x2, minus 2x times x cubed is minus 2x4, and minus 2x times minus 1 is plus 2x. So that brings us to that part, and this remains. And so then finally we get 3x4 minus 2x4 is just x4. 3 apples minus an apple. Plus 3x2 plus 2x. Divide all of that by x squared plus 1. Okay, so we do the same again for this one. V y dash is going to be our formula. U dash is going to be equal to 3. B dash is going to be equal to minus 5. So we can put these in now. 3 times 2 minus 5x minus 5 times 3x minus 1 over 2 minus 5x squared. So do your expansions. 3 2s are 6, minus 15x. Minus times a minus is a plus, so it's plus 15x. And a plus times a minus is minus 5. Divided that by 2 minus 5x all squared. What have we got here? 6 minus 5 is 1. Minus 15x plus 15x. So 2 minus 5x. So there's lots of opportunity in Pearson to study those, practice them. They're a bit formulaic, so I don't want to overemphasize it. If I'm going to emphasize anything, I'm going to emphasize the next one. Aha. These require the chain rule. Now moving forward into Math 1, you will need the chain rule, and you'll need to be very, very good at it. Okay? So a bit of pre-work. That'll mean that y is equal to x squared plus 1 in brackets to the power of a half. So we need to be able to do that. The next thing we do is assign some variables. So we're going to let u equal x squared plus 1. That allows us, and I'm going to make a fuss in another video on another topic, to go over here and write this as u to the half. So hopefully you might remember that. Okay. we're looking for y dash. Now, the chain rule is Leibniz notation. Please, Leibniz notation. It's NIT. Now, the reason this is important is because Leibniz notation one day I'll spell it properly. L-E-I-B. It's no T. L-E-I-B. Leibniz. L-E-I-B. Leibniz. Okay. Notation. And what that means is that instead of writing the dashes, which we did for those other things, naughty R's, we're going to write dy dx. Why is this important? For the following reason. We're still going to have dy dx, it's just that we're going through something else to get it. I wonder what that something else is. Looks a bit like rates, don't they? Alright, so when we've got our two equations, we can do Leibniz notation, u with respect to x, and y with respect to u. So we're setting up our Leibniz notation. So we've had to do a lot of work. I've been on this for about 5 minutes. It hasn't all been about Leibniz spelling. So the important thing here is that how long does the calculus actually take? Oh, all right, well, let's do this one. The differential of u equals x squared plus 1 is 2 comes out the front, 1, 2, 1 comes off, 2x. The constant's got 0. Took about 3 seconds. Let's do this one. Half comes out the front. 1, 2, 3, a half, take 1 off. Now, I know we haven't simplified it, but the calculus is finished. We've been mucking around with this question for quite a bit. So a half minus 1, I know that you will say is minus a half, but humour me please, because the habit is that you will get used to adding and subtracting fractions. So that's minus a half. Now, we want to put this together as a chain rule. So we're going through to u. dy dx through to u. So the first dy to u is this one. So it's 1 over 2 the square root of u times 2x. So we put them together. 2x over and change the u back. And the u was x squared plus 1. And they will cancel, and we're left with x over the square root of x plus 1. Ooh, there's our final chain rule. So this is quite a big deal. Okay, getting to come to terms with this is no simple matter, and it's not something that you can think or any less of. Okay, it's very important that we make a big deal about this. Okay, because there's a technique that we'll learn in calculus later that relies heavily on this. All right, so we can rewrite this using the pre-work. Now it's the cube root, so it'll be to the power 1/3, 5x plus 2. So we're going to let u equal 5x plus 2. So du dx will be equal to, this means that we can do y equals u to the third, and dy du is equal to, now I haven't finished them, because I want to build a chain rule. I want to take this, we want dy dx. And we're still going to have dy dx. We're just going to go through something else to get it. And the something else is invariably du. Now, it could be something else, depending on whether we chose u or some other thing. If this changed, the du part would change. So we've pulled all that together and haven't done any calculus. So what's the du dx of this? Well, that'll be 5. That was quick. The y du of this will be 1/3 u, 1/3 minus 1. Done. Now we've got to do the algebraic gymnastics. 1/3 minus 1, same family. 1 minus 3 is minus 2/3. So this is now minus 2/3. So 1/3 u to the minus 2/3. So 1/3 radical cube root u squared. And u was 5x plus 2. So this one's going to be 1/3 the cube root of 5x plus 2 times, what was our other one? 5. So overall we get 5 on 3 the cube root of 5x plus 2 all squared. Okay, now I can't overemphasize the importance of this. And the good thing about it is we can use technology to help us. That's right, you heard me. We can actually differentiate. And the differential is differentiate. Now there's another way to do that, and I'll do that in a little while. So it's going to be y equals the cube root. So I might put it in bracket form. 5x plus 2. Just to make it a bit easier on Wolfie. And what is it? The cube root, so it's 1/3. Let's see what that cops up. And what we see is it's processing like we would. It's recognising the cube root of 5x plus 2 with respect to x, so that's great. Ooh, 5/3, 5x plus 2 to the power 2 on 3, which is the same thing as what we had, okay? I just didn't do that step. So it's done exactly the same thing. Now look at this. This is the beauty of this. D dx. It's going to understand how to do that. Nope. If it will, if I take that out, I'm pretty sure it will. Yeah, it's going to differentiate that. I have to explain that. We're going to have a look at that later. All right, so we'll look at this just to do this as a final example, and then I think I'll pause the video there because we're kind of coming up to time. All right, so a bit of pre-work. Y will be equal to x cubed plus 4x to the minus 2. We brought it up the top. That's the reciprocal rule. Okay, so we're going to let u equal x3 plus 4x. So that means y can be equal to u to the minus 2. Very good. dy dx is still going to be found. We're just going to go through something else. And it looks like du, so I missed a little part there for you. So we need to become very, very proficient at this. So dy du minus 2u minus 2 minus 1 is minus 3. Du dx in Leibniz notation is 3x squared plus, it didn't disappear. So just do them piecemeal. So these are our products. Here times here. So we've got to put them together as such. Now u is going to be put back with a minus 3 as x3 plus 4x times 3x squared plus 4. Now it turns out, of course, that the minus 2 term can go down below, okay, and or the minus 3 term can, so it's a quotient again, okay. Now you can't easily put the minus 2 through there because of that minus, so leave it, okay, leave it at the top. These are all products, so we're going to end up with minus 2, put a bracket, 3x squared plus 4 divided by x3 plus 4x all to the power 3. Okay. So the simplification will come, we can do that expansion if we want to, which would be simplifying, and that would be okay. So we'll do that. Minus 6x squared minus 8. So there you go. We can do that. So differentiate again. And what have we got? 1 divided by x cubed (4x) to the power 2. I think I might have left a bracket off there. X cubed plus 4x squared. I think that's the correct question. That's what we got. But I did the expansion. Okay, so least as good as Mathematica. So that's important for you to recognise. So it is a rigmarole. The chain rule is your work. Now, if you want to become confident at mathematics and calculus, it's not a problem. The calculus is very straightforward. It's managing everything related to that. Okay, and that's the difficulty of this particular section. So anytime we get a chain rule, it's something that we have to bear. All right, because we need to learn how to do chain rules. We cannot leave this subject not knowing how to do chain rules. Okay. All right, so that means we'll get plenty of practice in doing them, and I'll return on the next video. Thanks.